Hello everyone, you are welcome to today's lesson. And in today's lesson, we are going to look at the solution to the core math class test on probability. This is Mr. Hackman, your facilitator for core math and elective math on Omega Vacation classes. Please take and stay with me whilst I walk you through the solution, which also happens to be the marking scheme of this particular test. Okay, so quickly let's move on to the next page. Okay, so this is what we have here, our next slide, and that's where we have the solution to the class test, starting from. So with this one, you can see I've told you anytime you read questions, make it a habit to underline the salient part. So assuming we have this question before us, okay, as I read, okay, so I will underline the salient part as you've been advised to. Okay, so in this case, let me see if I can pick the laser pointer. So let's read question 1A. A box contains 3 red marbles, 2 blue marbles, and 5 white marbles. A marble is selected and its color noted and then not replaced. So you know here, this is very critical. This information is salient and must be underlined. That will tell you the kind of probability that you are dealing with. Okay, so we are dealing with not replacement, selection without replacement. And that is informing us that we are going to deal with independent what event? Independent? No, dependent event. Because when it's not replaced, you should know the probability or second selection will be affected. I'm talking about the probability. Okay, so find the probability of selecting I, 2 red marbles, I, a blue marble, and a white marble. So as usual, having read the question, underline the salient part. What do we write first? Solution. Questions are numbered because we want you to equally number your solution. So you can see that here, okay, we have question 1A, and that's what we are looking for. And again, you should remember the advice. Anytime in any probability question, you have items and the items quantified, you know they are numbers. Okay, you should always try and present your solution this way. Okay, get a representation for your items in terms of sets. Okay, then after, because we know probability is strongly linked with sets or to sets. So what do we do? Okay, here we know, okay, we are dealing with a set of marbles. Okay, so on that note, it means our universal set, which in probability happens to be the sample space, we are going to represent that by S. So you write let S be equal to your set of marbles, and R will be equal to the set of red marbles, B will be blue marbles, and white will be a set of white marble. Remember, okay, you don't see marbles there, but because these colors are subsets of what? Your sample space, you should know that which happens to be marbles. We are dealing with what? Red marbles, blue marbles, and white marbles. So if you want to add marbles, you can. But the information that we have here is concise and precise. Okay, as well. After that, remember, after getting your representation, which must be in the set form, what do? You come and extract the information using the set notation. So the number of S will be equal to the sum of all the 3 colors. Okay, so marble. So you have 2 plus, what's that? 3 plus 2 plus 5, and that will give us 10. The number of red, okay, R, which will be red marbles, will be what? 3, blue will be what? 2, then the number of white will be what? Will be 5, just as we have extracted here. So at this point, this is what general information that you've extracted from the question, you extracted mathematically. Okay, and you are going to rely on this general information to solve question 1, I and what? And AI and II. Okay, so take note. So at this point, what do? The first probability, you are asked to find, okay, so you can see P, okay, and you know you don't write probability in full. We are going to use the notation to show maturity. So it will be P, which represent probability of what? Selecting 2 red marbles. And that is what we have here. So again, okay, I think I'm going to write here, so later I can go for. Remember, because here, this time around, your selection that you are dealing with, okay, your items, you are dealing with same item on each selection. So we are going to talk about, okay, your first selection being red, your second selection is also red. So you are dealing with the same color, and you know you are selecting two what marbles. So in this case, if your first is red and your second is red, you know you have only one possibility. Remember, first is red, second is red, they are the same. Okay, so if you use R sub 1, R sub 2, and you come and swap 2, okay, and you still have R, you swap, that will also give you R sub 1, R sub 2. So it's basically the same thing. So when you have the same object that you are selecting in this case, you have one possibility because you have only one way of what arranging, okay, your red and red, two reds. So in this case, this is what we have. So our first selection, remember, we are going to select what R, and it can be, you can write it as R sub 1, okay, and R sub 2 or R sub 1 intersection R sub 2. Please take note. Okay, let me go for the laser. Okay, only that I wrote it this way. It represents the same thing without the intersection, without the end. It's the same thing. You know that you are multiplying. And multiplication, you know, because this time around you are dealing with what do you call a selection without replacement. You are dealing with indirectly, okay, in fact, not indirectly, you are dealing with dependent events. So your first selection, you are going to have what? 3. Okay, it will be 3 red marbles out of 10 because you have, okay, your red for your first selection will be 3 out of 10. Now, because the first red was not replaced, if you are going for your second red, it will be R sub 2, given that R sub 1 has already occurred. Okay, and if R sub 1 has occurred, we know that your first red was selected and was not replaced. So in that case, if you are going for your second selection, okay, your number of reds will reduce by 1, making it 2. And also your sample space will be reduced by 1, making it what? 9. So in this case, your second selection, which is the red second selection, will give you 2 out of 9. Okay, if you come and simplify this, that gives you 1 over 15. Okay, you can see the marks there. I will come to the penalties. And take note, I will equally address all the major concerns that I saw in your submissions. Okay, so immediately any concern that I addressed, okay, is something that you, okay, did. Okay, I'm talking about if I'm referring to you, okay, in terms of your presentation, you check and do the needful. Okay, and so that you take note of it for you not to repeat it again. That was just by the way. Now we are done with I. What are we supposed to find? We are supposed to find probability of selecting a blue marble and a white marble. So P, a blue marble and a white marble. In fact, it shouldn't be a blue marbles. It's supposed to be a blue marble. So I will do the change, okay, later. It's a typo error. You should know. S shouldn't come with S. So pardon me for that. Okay, so this will be equal to, okay, now if because this time around the colors that you are selecting, they are different colors. Okay, they are different colors. You should know. Okay, distinct colors. You should know that here you are not going to get only one possibility. So this is the situation. Okay, you are looking at a blue marble and a white marble. So you should have a blue marble and a white marble. So if your first selection is blue and your second selection is white, okay, satisfy the blue marble and a white marble because the order was not specified. And again, if your first is white and your second is blue, okay, satisfy the same condition, a blue marble and a white marble. So in this case, we are going to have two possibilities, the first possibility or the second possibility. Okay, so now let's go and look at each possibility and how to find the probability. So the first possibility will be your first selection being a blue marble and your second selection being a white marble. So if that is the case, then that will give us P, B1, okay, W or sub 2. So in this case, you are going to get, you know, you are dealing with these two events are dependent events. So we are going to deal with multiplication. Okay, so again, if you wrote and or intersection, okay, it's allowed. There is nothing wrong with that. Okay, so what do we have? Your first selection, remember, must be blue. So when you are going to select, you have 2 blue marbles to select out of a total of what, 10. Okay, so that will be it for your first probability of getting a blue marble. Your second probability, which will be probability of getting a white marble on your second selection, will be the white, you know, will be what, 5. But you should know, though the white, okay, marbles not affected by you selecting your first selection being a red marble and not replacing, you should know that your sample space will be affected because you didn't replace what the first marble which happens to be a blue marble, which was not replaced, the sample space will be affected. So in that case, you are going to get 5 red out of a total of what? 9. Okay, so that explains how to find the probability of your first event that you have. Then you come to the probability of your second event. So what do we have? A compound event again. So it will be, so if your first selection is white, you have 5 out of 10 to select from. Now, because the white that you selected, the first one was not replaced, okay, your white will be affected. However, your blue will not be affected, and your sample space equally will be affected. So if your second selection is blue, you still have 2 blue marbles to select out of a total of this time around 9. Because the first selection was not replaced, your total marbles will reduce by 1 again. Okay, so that gives us what you have here. Use your calculator to do this one. Okay, so let me pick. Okay, so you use your calculator to do this, which will give us, or you can do this mentally. This will cancel, this will go here. Okay, 5, this will cancel, you get 1/9. Okay, you come and do same here. So that will give us what we have here. Okay, all right. So in this case, this is exactly what, okay, we should have here. Then after that, use your calculator. Okay, or you can even use your, since the denominators are the same, it's your common denominator in your numerator you add. So that gives us the result that you have here. This explains, okay, the solution to question 1A. Let's come to question 1B. And after that, I will walk you through the penalties. Okay, so with this one, question 1B, if a fair coin, so you underline a fair coin, and an unbiased die, okay, you underline unbiased die. Okay, what is are tossed ones? What is the probability of having, okay, I, okay, this, then I, okay, what we have here as well. So B, here we need to know our outcomes making the sample space. Okay, so just as here we knew, okay, so that we will know the number of sample space and your number of events as well. So if you want to get your outcomes making your sample space, therefore your number of sample space, we need to construct this table, or better still, you can use the tree diagram. Only that I advise you, if you have this, the table, okay, approach will do. So you are looking at what? So let me, a fair coin. Once you have a fair coin, you should know that, okay, the outcomes, okay, will be head or tail. So let me refer to this as what? Coin. Okay, and this will be what? Your die. Okay, so die, the outcomes on the faces of what? Your die will be 1 up to 6. Your coin, the set of possible outcome will be head tail. So now you look at the combination. So H1, H2, okay, up to H6, T, okay, 1. Okay, so let me go for T1, okay, T2 up to what? T6. So you construct your table. So now this will be the set of possible outcomes. So now what do we have? You come to I. Once you know your set of possible outcomes, you are in a comfortable lead. Any probability you should be able to find. Okay, so P ahead, a 2 and ahead. So therefore P a 2 and ahead will be equal to, so the only outcome, okay, so your event is this. So the only outcome that will satisfy this event, okay, will be this. So this will be the success. Okay, that's the only outcome that will be a success. That contains a head and a 2. Okay, or a 2 and a head is the same. Okay, so in this case, we are going to get, okay, 1 out of a total of 12. Remember, this will be 2, this will be 6. So it will be 2 by 6, which will be what? 12. Or you can still count the outcomes and you will still get what? 12. That will be your number of what? Sample space. Okay, so that will give us what we have here. Okay, so you can see the mass allotted. Okay, then what are we supposed to find? P, a prime number, and a tail. A prime number and a tail. So you are looking at probability of having a prime number and a tail, and that is represented in terms of the notation by P in brackets, a prime number and a tail. It's read probability of having a prime number and a tail, or selecting a prime number and a tail. So it means here we are looking at what? The outcome that will satisfy this condition, that will contain a prime number and a tail. So it means none of the outcomes here in this row, okay, will be a possibility. So because we are dealing with tails, so you come here, your concentration should be here. So if you are looking at a prime number and a tail, if you don't know what a prime number is, okay, at this point, okay, you struggle. And we all know what prime numbers are. Numbers with 2 factors, okay, 1, okay, and itself, and the number itself. So if you take this, Okay, 2 is a prime number, so it means there's a possible outcome. It contains a prime number and a tail. Okay, 3 is a prime number. Okay, so it contains a prime number and a tail. 2 successes so far. This is not a success. 4 is not a prime number. However, 5 is, 6 is not. So it means we are going to get 3, okay, successes. 1, 2, 3. So our number of successes will be 3 over the number of sample space, which we've determined that already to be 12. Okay, so now you come and simplify this, which gives us 1 over 4. Okay, so that would be it for question, okay, 1. And please take note, the total marks for question 1 will be 35 marks. Okay, and when it comes to the table, it will be minus 1 for each error. Minus 1 for, so any table outcome, your value here, that is wrong, minus half. Take note. Okay, and again, those of you who started with implication, you know, at this point, you should know, okay, or at this stage, you should know when to use the equal to and when to use the implication, which I've said times without, okay, a number. So what do you do? If you write implication here, it will be M0, A0. Each step, you introduce that with equal to because you are dealing with an expression. What you are asked to find is an expression. So equal to equal to equal to, then your therefore should be there. It's either you put your therefore here or later come and draw your conclusion here. Take note. Okay, that explains question 1. Now let's quickly go and look at question 2. Question 2, let's read the question again. The probabilities that, okay, Manfo, John, and Ernest will pass an examination are, okay, 2 on 3, 5 on 8, and 3 on 4, respectively. Find the probability that, okay, okay, so all 3 will pass the examination, none will pass the examination, exactly 2 will pass the examination, then this will be Ivan. Please take note. Okay, it's a typo error. So this should be Ivan. So I will do the change later and send it to you. Or let me even pause and do the change. Okay, here. All right. Okay, so please pardon me. Okay, so I have effected the changes. Okay, the one with that was supposed to be marble, then I wrote marbles, and this one as well. So I took advantage to correct that one too. Okay, so this is what we have. Okay, so we are going to, okay, look at the solution. Remember, I told you, anytime you are given, okay, questions of this sort, okay, where the individual probabilities are given, okay, it will be better you represent your event by letters, okay, just for convenience sake. Okay, so that your presentation will be ideal. Ideal in the sense that it will save you time and space. So I told you, anytime you have probabilities of events, in this case, you can see that you are dealing with the event in actual fact will be Manfo will pass the exams, John will pass the exams, okay, then what, NS will pass the exams. So these are the events. Okay, the main event that we know the corresponding probabilities. Okay, however, remember I told you, if you have this situation in your representation, because you need to represent your event by letters for convenience sake, in your representation, don't have probability in it. So don't come and write, let M be equal to probability, okay, that Manfo will pass an exam. Please, okay, or examination. Please take note. It's supposed to be no probability. So you should read exactly as you have here. P, let M be equal to, not P. So let M be equal to, Manfo will pass an exam, J will be equal to, John will pass an exam, and E will be, NS will pass an exams. Okay, so this will be the best way to get your representation done. Okay, so at this point, you can say that it's without probability, other than because you know, immediately you label your event, you are going to use the probability notation, okay, to get your probability of the event. So if you bring probability here, how are you going to extract it in terms of the notation? Because if probability is here, in terms of the notation, it will be probability of which will be obviously tautology. Okay, so this means once you've represented your event by these letters, then this means or this implies that PM, you know that M means, okay, Manfo will pass an exam. So probability that Manfo will pass an exam is 2 on 3, just as you were given here. You do same for the J, okay, John, okay, then that of E. So equally what we have here. So at this point, let me see if I can get the laser for us. Okay, so now you know the probabilities. And if you read through the question, you know that, okay, here especially none will pass, you should know that the probability that you are going to find will involve, okay, the complement of what your main event. Your main event will be passing. So the other one will be not pass. If none will pass means, okay, now, okay, you have it like not pass. Okay, not pass. So complements will come in. So by that, after stating your notation in the probability of the main event of the event, now you come and equally that will guide you to find probability of the complement, which you know you will need. Okay, after you have scrutinized, okay, the entire, okay, question there. So in this case, you come and have P M bar, which will be the complement of M, will be equal to 1 minus P of M. So it will be 1 minus, okay, 2 on 3, which happens to be the P of M, which is equal to 1 on 3. You could have done that mentally. So you could have written P M bar is equal to 1 on 3. And remember, I told you to use the bar instead of what? The prime, okay, or the usual complement for sets. Okay, so probability we usually use the bar instead of what? The prime. Okay, sets that we use the prime to represent the complements, but probability we use the bar. Remember, I told you when I was introducing you to that. So you do same for pj bar, which will be the complement of j, 1 minus pj, which will give us this. Then pe bar, which will be 1 minus pe, okay, and that will give us this. So like I said, we could have, okay, written P M bar is equal to 1 over 3. You can do the subtraction from one mental, this from one mentally for each of them. Okay, take note. So now that you know the probabilities that you will need along the line, all of them, you come to your I. I, what are you supposed to find? P, all three will pass exams. Okay, the examination. So it will be therefore P in brackets, all three will pass the exams. Okay, or the exam in this case. So what do you do? Okay, that will be equal to, if all three will pass, it means Manfo will pass, John will pass, and what? NS will pass. So it will be Manfo will pass, and John will pass, and NS will pass. So in brackets. So obviously, you know, like N is for multiplication, intersection is also for multiplication. And the event, obviously, you know, are independent events. Okay, so in this case, this will give us, if you want to find this, it will be the product of the individual probabilities, the probabilities of the individual events. So what do we do? It will be PM times PJ times PE. You should know this mentally. So that step is skipped. So I'm going to find PM. PM, probability of M, I know. The question gave me that 2 on 3. Probability of J, the question gave me that is here 5 on 8. Probability of E, the question equally gave us that 3 on 4. So you use your calculator or you do this mentally, and that will end you with this value 5 on 16. And remember, your answers must be in what fraction unless otherwise stated. Avoid decimals, I've told you. Okay, if possible, unless otherwise stated, avoid decimals. Okay, so in this case, what do we have? That will be it for I. What are we looking at? None will pass the exam. So P, none will pass the exam, which is where probability, none will pass the exams. And in this case, this one too, you have only one possibility. If none will pass the exam, then it means, okay, Manfo will not pass, and John will not pass, and NS will not pass. So that is what we have here. And in this one, someone could have got this, okay, first step here down. Okay, so, and you can see that when I brought it here, I didn't let the equal to be in line. Remember the advice, as you move from one line to the next line, if you are going to write, you write close to the margin. So I have heeded, okay, that advice. So now what do we do? This will equally give us P of M bar times P of J bar times P of E bar. So you should know this, okay, mentally and come and deal with it. You don't write it. So P of M bar, you know, that is what you found with the individual probabilities, the probability of the event, the main event. So that will be 1 on 3. P J bar, that is 3 on 8. P E bar, that is 1 on 4. So you substitute, simplify, and that gives you 1 over 32. So this takes us to I. Okay, I, what are we looking for? Exactly 2, okay, will pass this. So it will be there for P, exactly 2 will pass the exam. So if exactly 2 will pass, then it means, okay, at any point in time, only one person, okay, will not pass. So if exactly 2 will pass, then it will mean maybe, so usually I want to move in this direction. so that I avoid conflict. Okay, so my first name will not pass. The other names will pass. Okay, then I move on to the next one who will not pass will be the next name. So that's what I have. So it means here I'm going to have three possibilities. The first one will be Manfo, okay, failing, and the other two passing. In this case, you have, okay, exactly two passing. Okay, or you can have only John, okay, will not pass, but Manfo and NS will pass. So this one too gives us another possibility for, okay, two passing. Then if you come to the third one, okay, NS will fail and the other two will pass. So you can see that the complements, okay, started from M, moved on to J, then moved towards the last one. So that's how I usually do mine. Okay, so this is, so if you say exactly one will pass, I will start with the first two complements, then keep on moving. Okay, all right, my compliments. Okay, so, but that was just by the way. So in this case, this will equally be, once the events are, I should have stated that here, once the main events are independent, the complement will also be independent. So same here. Okay, so this will be the probabilities, okay, of the individual event, okay, multiplying, be it the complement or the main event. So it will be Pm bar times Pj bar times Pe bar. Okay, Pm bar will give us, you know, so you go and extract the individual probabilities and come and substitute. Pm bar will give us 1 on 3. Pj will give us what? 5 on 8. PE will give us what? 3 on 4. So you substitute. Or, okay, and that will be plus. The or is what I have replaced by plus here. Someone can use the or here, and now change it to plus here. It doesn't really matter. Okay, so at a point you should change to plus. Maturity here, because I know that I'll write or, so plus, or plus, it will change to plus. So in this case, okay, that will be it for my first, okay, probability of my first event, compound event. Let me come here to probability of my second compound event. This will give me Pm, okay, times Pj bar times Pe bar. Pm is 2 on 3, so you know it's here. Pj bar, okay, is what? 3 on 8, and that is what you have here. Then Pe, okay, is 3 on 4. That's what you have here. Then the last one too, okay, is similar, so the explanation is the same. You come and substitute. Don't use your calculator to do the whole of this. Okay, use your calculator to compute it term-wise. So compute this mentally or using your calculator. Okay, and if you do that, you get 5 on 32. Okay, your second, okay, one will give us 3 on 16. This will give us what? 5 on 48. Okay, so now you come and sum everything together using your calculator, and that will give you 43 on 96. Okay, that will be it for the III. Now, the last one, okay, therefore, so the last one, we are looking at P, at least one will pass. So it will be, therefore, P, and in brackets, this will be your event. At least one will pass. And in this case, you underline at least, very critical. So assuming, okay, this is because at least one. Remember, I told you any probability question that you see at least one, there is a convenient way, okay, of dealing with it by relying on a particular relation, which will be 1 minus P none, and it will be none of your events. So the event here we are talking about will pass. Okay, so it will be P none will pass. Okay, unfortunately for us, we've done P none will pass. So we just go and infer, okay, from what we have here. So it will be 1 minus, okay, P none will pass, which gave us 1 on 32. Remember, if you are inferring, you have to be very sure that your calculation here is right. Otherwise, if this is wrong, you get it wrong from here down. So that will give us 1 minus 1 on 32, and this gives us 31 on 32. Okay, so that will be it for the question 2. Again, okay, if you put implication anywhere here, okay, it will be M0, A0. Take note of that. And make sure as you move for some of you, you did that. It's not costly anyway, but it is an advice. Heed to that advice so that in case you need a rough work, you can come and continue. Okay, or do your rough work here, device. So always move your work to the side, which again, most of you didn't. Okay, all right. And those of you who defined, I think I'll come to the penalty. Say, I'm done with the question 2. So if you define your probabilities, I mean your event here to involve probability, okay, you will get a B1. Remember, it will be B1. I should have given you B0 because I have been saying that I think I have to, okay, I shouldn't be lenient. That will be B0. Okay, then if you come here, if you wrote P this, okay, M is equal to P, manful will pass, and you come and write this one, this will also be B0. Okay, and this will be equally be B0 because it will be tautology. So you are going to lose 6 strong marks, good marks. So take note of that. So it's here that, okay, so your representation should be right from the onset. So take note of that. Okay, that will be it for question 2. Now to our last question, question 3. And again, let me quickly say question 2, the entire mass there will be 37. Okay, so let's go and look at question 3. Question 3, okay, so this is the question, just so you can see. Okay, I don't want to walk you through the question. Okay, all right, so let's quickly go and look at the solution. So again, the first thing that you write is solution after reading question 3A. Okay, then you come and write solution to which question number? Question 3A. Question number, solution must be numbered. And I told you, anytime you have a table provided, okay, if you think you need to add extra columns or extra rows to your table, reconstruct or redraw your table and what? And attach with those rows or columns that you think you will need. So that's what I did. I know that from here, I knew that I would need the totals. So I will go and create a column or row for what's the totals. Okay, and you know that this is a question that we've seen before. Okay, in fact, the whole of question 3 is supposed to be a bonus question. It's a question that we handled in one of our lessons. Okay, it was loaded, but I took part. Okay, all right, so now let's look at the A. That was just by the way. What are we supposed to find with this stage? So what is the probability that the prefect will be I, a boy? So we are looking at I, therefore P in bracket, a boy, and that will be equal to, so it will be the total number of boys over the total number of students, okay, in the 3 classes. So in this case, your total number of boys, where do you get the total number of boys here? Okay, this is where you have your total. So 42 over your total number of students, which will be 96. This can be reduced. You reduce that. Okay, then we come to II, the second question. We are looking at P, okay, a girl in class B. So your number of success will be number of your event here. So number of girls in class B over your number of what sample space. And your sample space, you know that is 36. Sorry, 96, forgive me. So in this case, we are going to get number, okay, of your success, which will be the number of girls in class B. Okay, so we come to the table. Where do we have number of girls? So this is the class B. The number of girls in class B will be 22. So you get 22 over 96. Okay, and that will be equal to 11. You can simplify. Or 47. You can see that, okay, something that I barely do, and I've advised you again. Okay, at the normal circumstance, this step here should have gone down, should have been equal to, then should have come down, just as I did in this situation. But because I needed space, okay, that's the more reason why I pushed it here. In your presentation, it should be down. Take note of that. I've advised you, avoid writing more than 1 equal to on the same line. And you can see that you have more than 1 equal to on the same line. So your next step, which is this, should have gone down. That was okay. I think that is explicitly okay, uh, determined or said. So now what do? We come to the B. B, what is the question? A fair die is tossed 2 times. Calculate the probability that the, okay, so these probabilities. So you are dealing with a fair coin, but that is tossed twice. Okay, you can use the tree diagram, okay, equally to extract our sample space. However, remember, we usually will resort towards the table approach. So your first die, the outcomes will be 1 up to 6. Your second die, the outcomes will be 1 up to 6 as well. So if you want to get the various possible combinations, okay, that will give us the set of possible outcomes in the sample space. That's what you have here. So it will be 1, 1, 1, 2, 1, 3, up to 1, 6, then 2, 1, 2, 2, okay, up to. So you know how to construct the table. If you have forgotten, go and review the lesson on that. Okay, so at this point, once we have our table constructed, what do? We come to I. Okay, I, what are we supposed to find? Okay, you are also finding the probability that the outcomes, okay, contain at least a 3. So it will be therefore P outcome contain at least a 3. And that will be equal to at least a 3 means, okay, your numbers making the outcomes, at least one of them should be a 3. So it means you can get two of them to be a 3, which is a possibility. Okay, so let's pick that. So this is a success. Okay, if you come here, the one that contains a 3, a success, this row 2, okay, the whole, this is a success, this is a success, this is a success, this is a success. For this row, okay, you have, and for this row, you have only this to be a success. The next row, this to be a success. Next row. So if you count 1, 2, 3, 4, 5, 6, okay, so let me count well with there so that you follow. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that will give you 11 over 36, which, okay, we cannot what reduce. So that gives us the answer. That's so M2A2. Okay, so now the method mark will be how you got your 11. Okay, and okay, that went through how you taught. Okay, and that's what you then you come to II. Okay, therefore, what are we looking for? P sum of outcome is 8 or 10. Okay, and that will be equal to, so you can see all there. The connector is all. So it means we are looking at P sum of outcome is 8 or P sum of outcome is what, 10. So I decided to be concise and precise here. So this is P sum is 8 plus P sum is 10. If you write P8 plus P10, you are wrong. They are not the same. P8 means P, your outcome is 8. Not here, we are talking about the sum, not the outcome itself. Okay, take notes. Okay, so the sum of your outcome here, the outcome itself will be this, but we are looking at the sum of the numbers in the outcome. So if you wrote P8, P10, okay, that will be wrong. I told you in in one of your lessons where we handled this question, I don't know why some of you still decided to do that. You are not learning from your mistakes. That is the implication. So if you write that, it will be M0, A0 straight away. Take note. Okay, so in this case, P sum is what? So let's go and look at, let me see if I can clear what we have there. Okay, let me clear. Or maybe I will use another way to identify the sum being 8. So P sum being 8. Okay, so let's see if you can. Okay, so this one, the sum will be 8. Let me use mine. Okay, so the sum, so this is a success, a possible success, sum 8, a success, sum 8, a success. So the diagonal here, a success, sum 8, a success. So that will give us 1, 2, 3, 4, 5. So that will give us 5 over 36. Then P sum 10. Sum 10, let's see. Okay, the possible sum, okay, that will give us 10. Okay, this is one of them. 1, okay, 2, then 3. So the diagonal here, so that will be 1, 2, 3. So or which is plus. Okay, so that will give us sum 10 will be 3 out of 36. Sum 8 will be 5 out of what, 36. Okay, and here someone can be smart. Okay, so write P sum is 8. Okay, okay, plus what, P sum is 10. Okay, you know, and bring the bracket. Or instead of writing, let me put this way, P sum 8, okay, or 10. You can combine everything here. So you can find the possibility, the successes, and put everything together to give you the 8 over what, over 36, which will reduce to what, 2 or 9. Okay, however, I decided to use the basic definition of the or to split my event for me to know that I will be adding the probability of the event that you have there. Okay, so on this note, okay, this will be it. You substitute your, you find, okay, the probability here using your calculator, and that simplifies into this, and that gives you the total mass to be 38. If you put the three, okay, total mass, okay, together, you are supposed to get 100 mass. So 100%. So you should know. Okay, here the penalty is every table that you have in question in the solution, take note, -1 for each error. With this one to -1 for each error. So wrongly stated, okay, output, okay, or outcome here, okay, should, okay, warrant or attract a penalty of what, 1. So you subtract 1, okay, to what you have there. And take note, if you hear somebody equally wrote this, instead of writing P
a boy. The person just wrote a boy is equal to no. A boy cannot be equal to this. There's a probability which you always have a numerator of a denominator. So immediately you write that it's M0, A0. You are finding probabilities. So it should represent exactly what you have there. So instead of writing probability that outcome contains at least a 3, that's why we have this notation there to guide you, okay, to save you time and space as well. Okay, so thank you very much at this point. Okay, so I think, yes, this will be it, okay, with the solution to the class test. Thank you very, very much for your time and your attention. Okay, God bless us all.